Welcome to Your Math Explained, where we make math simple and clear. My name is Angela, and in this video, we're diving into inverse functions. We're going to be talking about what they are, how to find them, and what they look like on a graph. So let's get into it. What exactly is an inverse function? Well, an inverse function basically undoes what the original function does. So let's say we have two functions here. We have our f of x, which is equal to x squared. And then we have our second function, which is g of x, and it's equal to the square root of x. Let's say I put 4 into our function f. So that's going to be f of 4, and that is going to give us an output of 16. Now let's say I take this 16 and I put it into my function g. So this is going to be g of 16. This is going to give us an output of 4. So you see, what's happening here is that it's reversing what happened in the first function. Because we had our original input, which is 4, we put it into f and we got 16. And then we took the output and used it as input for our second function, and we got our original input back as the output. So therefore, the functions f and g are inverses of each other. So in other words, if a function takes an input and gives an output, then the inverse is going to take that output and return you back to the original input. So now let's take a look at the notation. So this is what we call the inverse notation. So inverse of a function is written as f, and then we have this superscript -1, and then we have of x. So one very important point is that this is not the same as 1 over f of x. Because some of you might think that this little -1 here is an exponent, but it is not. It is just how we write and denote an inverse. So this is read as f inverse of x. So now let's take a look at an example. We have our function f of x, and it's equal to 2x plus 3. And we wish to find the inverse function, f inverse of x. So how do we go about doing that? Well, to start, what you do is you swap your x and your y value. So note that f of x, this is really just the y value. So we have y is equal to 2x plus 3. So to find inverse, we're going to take our y, and then we're going to take our x, and they're going to switch places. So meaning we start with x is equal to 2y plus 3. Next, we're going to isolate y. So we would move the 3 over, and we get 2y is equal to x minus 3. Divide both sides by 2, and we end up with y is equal to x minus 3 over 2. Now, you might think that we're done here, but there is one very important last step. So notice how the original question is asking for f inverse of x. We cannot leave our answer as y is equal to. So remember to do this very last important step, which is to replace your y with f inverse of x. And that is equal to x minus 3 over 2. So this is how you should be presenting your answer. So now, using f of x and f inverse of x from above, let's go ahead and find f of f inverse of x and f inverse of f of x. So f of x was equal to 2x plus 3, and f inverse of x, which we found earlier, was equal to x minus 3 over 2. So now, to find f of f inverse of x, what we need to do is put the function f inverse into our function f, meaning this is going to be 2 times x minus 3 over 2 plus 3. And then we're going to simplify this, so this will be x minus 3 plus 3, which is equal to x. Similarly, if we wish to find f inverse of f of x, this time we're going to put our function f inside of f inverse. So meaning this is going to be 2x plus 3 minus 3 over 2. So this is going to be 2x over 2, which just ends up again being x. So the important lesson here is when we have f inverse of f of x equaling to f of f inverse of x, and it's equal to x, which is what we ended up having here, then it verifies that the two functions are in fact inverses of each other. Okay, so now we're going to take a look at what the graph is going to look like when we have our original function, and then we want to plot the inverse function. So let me zoom out just a little bit so that the graph fits. Okay, so here we have our function g of x, and we've graphed it on this paper here. What we want is we want to sketch the function g inverse of x. So similar to how we solved solve for the inverse function f earlier, all we need to do is swap our x and our y values. So notice how here we have particular points on the graph. So what we're going to do is we're going to take each of those points and then we're going to swap the x and y value. Okay, so let's start with the first one. So this point here is -3, -2. So meaning we have our x value as -3 and our y value as -2. So to swap it, it's going to have an x value of -2 and a y value of -3, which means the point is going to be right over here. Next is this point over here. So this one is 0, 2, which means that's going to end up being 2, 0, which is right over here. And then our third point is 5, 3. So that is going to become 3, 5, which is up here. And finally, our last point is 6, 4. So that is going to end up as 4, 6, which is right over here. Okay, so let's go ahead and connect those dots. So we have this one, and then this line, and then finally this line. So what do you actually notice about these two graphs? Well, what's actually happening here is, let me go ahead and draw this this diagonal line here. Okay, so this diagonal line is y is equal to x. Notice how they're mirror images of each other. So that's actually what is happening for inverse functions. The inverse functions are actually just a reflection over the line y is equal to x. So this is also another easy way for you to graph inverse functions. You can go ahead and draw your line y is equal to x, and then just flip the graph over it, and that's going to be your inverse function. So now let's do a recap of everything that we have just learned. An inverse function undoes what the original function does. So it takes the output and it brings you back to the original input. And to actually find the inverse when you're given an equation, the steps would be to first swap your x and y, and then you solve for y. And then remember that there is that very important last step, which is to present your answer as f inverse of x. And then finally, when we're talking about graphing, inverses are reflections over the line y is equal to x. So if you're able to view what the function is going to look like once you do that reflection, then you can do it that way. But if you feel that that is a little bit difficult to visualize, then all you have to do is swap all the x and y coordinates of each point. So I would say label a couple of points on the original graph, swap their x and y coordinates, and then connect those dots, and that is going to be your inverse function. Perfect. So now, given what you have just learned about inverse functions, can you solve these two questions here? Leave your answers in the comments below and let us know if you'd like to see more content on inverses in the future. That's it for this video. If you found it helpful, remember to hit that like and subscribe. And if there's a topic you'd like us to cover, make sure to drop it in the comments.